Good morning, everyone. Welcome to the video lecture series of wireless cellular and 4G LTE broadband, module number 3, lecture number 4 in channel structure of LTE. Okay, so today we are going to see how this uplink FDMA radio resources will help to increase the quality of services. Okay, so based on the type of radio resources what we have studied in the previous video lecture, so here today we are going to see again how this can be used so that the uplink facility can be increased and making sure that it will be better as compared to other technologies. Okay, so once we look at here into the uplink radio resource, that too in frequency division multiple access. Okay, so this uplink in LTE, this uplink transmission is been one of the part of a very important type of multiplexing technology. Okay, and this particular SC-FDMA, okay, it is being considered widely in LTE system. Okay, because when we do compare with the conventional type of OFDM, okay, and different type of receivers which are not related to or which did not make use of the OFDM technology, okay, then during that particular condition your receiver will become very complex. Okay, therefore just to have a not not to make the more issues related to the uplink channel, okay, some of the powerful computational abilities are been designed, or you can say it has been decided. Okay, so basically this FDMA here is nothing but here both can be seen together as a trans receiver. Okay, that is taking the transmitter as well as the receiver. Okay, and some thing a kind of a similar structure is been designed for this particular type of multiple access. Okay, where the uplink frequency or the uplink channel, it will have the almost similar type of frequencies or similar type of the characteristics, similar type of features as compared to the downlink. Okay, so therefore we will see how this structure of LTE can be used in terms of FDMA. Okay, so first here is we will see about the frame structure. Okay, so whenever you go for any type of the mechanism, either in terms of uplink or in terms of downlink, okay, always we will come up with some kind of formats. Okay, so there are formats for the uplink as well as there are formats for the downlink. Okay, in this video lecture we will see about only the uplink structures or uplink frame structure. Okay, but only the difference between the uplink and the downlink is nothing but the symbols, that is FDMA symbols. Okay, and here they are FDMA subcarriers. And if you make use of for example the structure or a frame type of of one, okay, there are many types. We have one, type 2, type 3. Okay, it goes on. Okay, so if this FDMA structure is making use of type 1 type of frame structure, then it consists of, or the frames consist of 20 slots of 0.5 milliseconds. Okay, here we will speak in terms of the frequency division multiplexing, allotting some kind of frequency slots, or in terms of time of small delay. Okay, that is nothing but divising. You need to divide the slot into different number of multiple slot, assigning some amount of time for each subframe, you can say. Okay, so therefore they are allotted with 0.5 milliseconds each, and each subframe consists of 2 slots. Okay, and this complete is being shown in figure number 8 here. Okay, so in figure number 6.8, if you look into that particular figure, okay, that figure makes use of the whole complete example of the frame structure allocation of your LTE. Okay, so based on the type of control mechanism here, you can see in this particular frame structure of which is of type 1. Okay, so in type 1 here you can see there is one complete frame here. Okay, and they are being allocated in terms of time slots, and each time slot is of 0.1 millisecond. Okay, so this is one frame of 0.5 millisecond, this is another frame, and this will goes on. And what each frame consists of, for example, if this is a 0 frame, then it consists of again different types of multiple blocks. Okay, and we represent it in terms of OFDM symbols, which is of 66.7 microsecond. Okay, so this will go on doing in terms of the formats what we do have here in OFDM technology. Okay, so this is how the frame structure is been designed, or frame structure is been represented for such kind of uplink channels. Okay, now other than this FDM channels, okay, structure here, what you can see, okay, they makes use of some different fields, okay, some different blocks, okay, which is again shown in figure number 6.9. Okay, in that particular figure you may see different blocks are there. Okay, so this is how the frame structure is designed. The structure has been defined. You should define in before the development of your LTE protocol or LTE stack layer, or you can say simply the LTE stack structure or the network architecture. Okay, now once you come to the frame structure, you may come with different types of mechanisms here. So the very first here is nothing but a physical resource block, okay, for SCFDMA. Okay, what is this physical resource block says here is this physical resource block, it is been as again compared with the conventional OFDM, it makes use of DFT. Okay, because right now presently we make use of FFT algorithms and very advanced algorithms, but here the conventional OFDM is making use of the DFT based precoder. Okay, and the resource grid or the uplink is almost similar to one of the downlink. Okay, there is no much difference between the uplink and downlink here. Okay, they all are completely one together, or they are almost similar to each other. Okay, you can see here in this particular figure how their resources are allocated, like for 0, 1, 2, 3, some numbers are being assigned. Okay, whenever they fall under that particular number, then that particular channel or respective channel will be automatically activated so that it can be used in a proper way. Okay, even it has shown in figure number 6.12 the structure of uplink resource grid. There is this, the grid is nothing but the number of blocks. You can see this is the resource block, which is as a dark square box. Okay, and the small blocks are called as the resource element. Okay, so resource block consists of resource element of k comma l. Okay, and towards this part we see the number of subscribers here. Okay, and this arrow marks shows us the resource block. So these are the resource block. The total number of resource blocks will start from k is equal to 0 till k is equal to some number minus 1. Okay, so in simple way you can take it this structure which is along the time of, that is with respect to the symbol versus the sub carriers. Okay, and what this block consists of, or what this grid consists of, is grid consists of the frames. This is one complete radio frame which is of 10 milliseconds. Okay, and this one radio frame consists of different subframes. Okay, and one subframe consists of these many number of slots, and one slot consists of this particular resource element. Now for 1 again this block, for 2 again this block, and for 3 again this block, and it goes on. And why they have taken only 19? Because in the earlier they have mentioned as 20 slots. Here you can see there are 20 slots. So all 20 slots are being filled with the radio resource elements or radio resource type of which are radio resource elements or radio resource blocks. Okay, which can be used in the uplink transmission, okay, of any bandwidth, or depending on upon the bandwidth which they have specified. Okay, now as compared to that particular diagram, they make use of some kind of this delta frequency, which are nothing but used for the spacing between the two bands, you can say, which is of almost 15 kilohertz. Okay, and again it is different from the downlink. Okay, where there are different again subcarriers which are used in the uplink. Okay, there should not be any kind of interferences spread over the modulation, or during the modulation there should not be any kind of interferences. Okay, now similarly when it comes to the downloading mechanism, here each resources in the resource grid is uniquely defined by the pair of k comma l. Here you can see in the figure, right, these all the blocks here which they are shown, they are unique to each other. There is no any kind of repetition of blocks. Okay, so that is why the reason they all are uniquely defined by this particular pair, that is k comma l. Okay, and it is also possible that you may also assign some kind of indices in the frequency and in the time domain respectively. Indices is nothing but you can give some numbering to that particular time slot or numbering to that particular pair. Okay, and that pair will help you to show the which type of resource elements are used. Okay, and for uplink we require the antenna, right? And where the antenna, it can be either the Mimo antenna, that is multiple antenna, or it can be a single antenna. Okay, if you are making use of a single antenna here for the transmission, then it should then that should be supported in the current specification. Current specification in the sense it should accept all the 20 slots, which is of 0.5 millisecond. Okay, based on that particular 0.5 millisecond, the allotted time slot should be accepted. Okay, so this is how we go for designing the structure of LTE. Okay, now other than this particular structure of LTE here, okay, in this particular concept of FDMA, symbols in time domain, okay, or it can be in the frequency domain, some of the corresponding slots in the time domain, they are making use of some 180 kilohertz of frequency. Okay, it depends how much amount of uplink they want as a frequency and how much amount of downlink they want into their frequency. But here in frequency they are making use of 180 kilohertz of frequency. Okay, and again there is a relationship between you can say relationship between your uplink and downlink. Okay, so based on the number what they have shown here, they have been making use of some formula here, that is neta PRB is equal to K divided by NC into RCB. Okay, so this is how the physical resource blocks for OFDM they are allocated. Okay, how you are allocating the resources for FDMA, they have shown there should be some mathematical formula, right? So based on that, these formulas what they have shown, they should not be exceeding the number of blocks. If the blocks are exceeding, then there is a loss of the resources or unutilization of resources, where it becomes the problem for the uplink for the transmission, because it becomes a load. There should not be a maximum load, because the handling capacity should not exceed beyond that particular range. Okay, so this is how we go in LTE mechanism. Okay, now once we study about the physical, then we should know about the resource allocation. Okay, so similar to the whatever the downloading facility what we have seen. Okay, so resources allocation should not be independent. Okay, there should be in a shared channel transmission. Okay, because what happens is all before the transmission, all the channels are dependent. Okay, and they are already scheduled for the uplink. Okay, already their links are scheduled, already the channel is been allocated for each users. Okay, and if the resources are not shared, then the amount of time what we may take is it may become more. Okay, and the resource allocations in the uplink is also performed at E node B. Okay, and based on the channel capacity measures, the uplink sounding references signal and the scheduling request sent from UB and E node B assigned to unique frequency resource to a schedule UE. Okay, so this is how they do in the resource allocation. There is one more important topic here in the resource allocation. It says that the amount of significant coverage and the capacity gain in the uplink over UMTS employs non-orthogonal transmission. Okay, what we see in OFDM is they all are orthogonal. Okay, but here the transmission makes use of the non-orthogonal transmission during uplink mechanism. Okay, what if we do in non-orthogonal, then the performance can be limited. Okay, here we can go for the limitation of the performance. Okay, here you can see where the channel interferences can be reduced as much as possible. Okay, so in this way we go for doing it in a proper manner. Okay, then apart from that, here the again the current in the specification only localized resource allocations are supported in uplink. Okay, and again they make use of single carrier property and can be better exploit to multi-user diversity gain and in frequency domain. Okay, always there should be some mechanism behind the resource allocations. Okay, if you get to know how this can be done, then it becomes very useful in allocating the number of resources for the uploading for uplink, or it can be in terms of downlink also. Okay, now the last here is supported Mimo modes. Okay, once we have the physical and once the resources are allocated, then we need to go for supporting the Mimo systems. Okay, so Mimo is basically nothing but it's a multiple input and multiple outputs. Okay, so these Mimo systems can be supported in the uplink as well as in the downlink. Okay, that is the first case. And the second case is based on the type of complexity here. If because whenever you use you make use of more than one antenna, there is a possibility that your capacity may get increased. Your complexity may get increased. Okay, once the complexity increase, then there is obviously there is a condition that your cost may also increase. Okay, that is the main concern here. Okay, so therefore the multiple MIMO systems are supported in this particular LTE system. Okay, which allocate the same time and frequency resources to two user entity with each transmitting on a single antenna. That is what the specialty of the MIMO systems. Okay, and how this can be done? They are done in the spatial domain. We have seen, right, the spatial multiplexing. The concept of spatial multiplexing will come into existence. So that is why the reason we change it to the SDMA, that is spatial division multiple access. Instead of going for your TDM, FDM, and CDMA, we go for spatial division multiple access, which makes use of orthogonal. Okay, so because of that, it gives you various advantages. The advantages are nothing but you can here the transmitting antenna per user entity is required. Okay, and other than that, to separate the streams, because I'm just multiplexing all the streams, then I need to separate the streams for different user mobiles. Okay, for different channel, so that they contain different information. Okay, based on the requirement. Therefore this can be used in this can be made possible if you make use of the MIMO systems. Okay, and other than that, there should be always the orthogonality, or the channel should be orthogonal, or the signals should be orthogonal between the each user entity. Okay, and based on this uplink MIMO system, it requires the power control. Okay, as the near far problem arises when multiple user entities are multiplexed, because one user entity cannot be at the one place. Okay, one will be at one point, another will be far beyond that point. Okay, so if the distance is varying, then there is a problem of arising the power issues. Okay, because less the distance, less power consumption; more the distance, more the power consumption, right? So based on the requirement of the user entity, what we have multiplexed at the beginning of the transmission, okay, it requires the some kind of power control. Okay, there should not be utilization of more power, there should be some minimum power utilization. Okay, so therefore this can be done. And other than that, the user entity with if they having more than two or more transmitting antenna, closed loop adaptive antenna selection transmitting diversity shall be supported. Okay, this is the mechanism, that is adaptive modulation. You know what is the concept of adaptive modulation, right? So therefore, if one mobile is making use of two or more, two to three, four transmitting antennas, if we have, then we may go with the adaptive type of antenna selection. Okay, antenna selection in that particular transmit diversity, because we come across the two type of diversity. One is the receiver diversity, another is nothing but your transmit diversity, and that will support for this particular MIMO systems. Okay, with this, the complete radio resource mechanism is been concluded in a better way, such that not only the performance of the LTE is increased, along with the performance, the quality of services can be shown in a better way. Okay, so with this, I conclude this today's topic here. Okay, thank you.